Good morning.
Morning.
Today we are here with Rita Baranwal, the Chief Technology Officer of Westinghouse, and we're going to learn a little bit about her journey to this moment and some insights on nuclear energy. Rita, how did you get into the nuclear field?
Well, my first job after grad school was actually using some of my graduate work to develop new nuclear fuel for the U.S. Navy's aircraft carriers and submarines that were powered by nuclear power. So it was almost by happenstance that I came into the field, but I have been here ever since, and that was over 25 years ago.
Wow, incredible. The Navy's probably our best source of building new reactors in the U.S. right now, right?
Correct.
Are we able to utilize any of those skills, that capacity to help us decarbonize now?
Yeah, so they can definitely help us in constructing new reactors, but even more so, once the servicemen and women have done their tenure with the Navy, we welcome them to join the civilian nuclear power industry because we can absolutely leverage their great experience.
Wow, amazing. So you've had a few different looks at the whole industry. From both inside the government and outside. Curious, what was it like being the Assistant Secretary of Nuclear Energy, I want to say? I feel like there's a longer version of that title.
That's it.
That's it, okay. Yeah. All right, so what was it like being the Assistant Secretary of Nuclear Energy?
So in DOE, it was really important that somebody with technical experience be in that role. There was a lot of, So as Assistant Secretary for Nuclear Energy in the Department of Energy, it was a very impactful role. The technical experience that I brought was valuable because sometimes in some of those meetings, while there were a lot of policymakers and a lot of folks that understood government, there weren't that many folks that understood the technology. So it was important to be at the table. It was important to have that voice at the table. And I'm really proud of the work that we did.
Yeah, I mean, just looking back over the last 6 years has kind of been transformative for the industry in terms of saving the remaining plants that were in danger of closing, and now all the new funding that's going towards advanced reactors. It's incredible. So now in your new role at Westinghouse, what's that look like from your position? What sort of pieces are you seeing on the chessboard? What's coming up?
So Westinghouse is a global nuclear industry company, and we have a range of reactors to offer to our existing customers as well as new potential customers. So starting in terms of size, we have our eVinci reactor, which is a 5 megawatt reactor. Next in size, we are going to be launching our SMR reactor. And then we have our lead-fast reactor concept, which is a 450 megawatt reactor. And finally, already constructed and operating in China, our AP1000 reactor. And then at Vogtle 3 and 4, AP1000s as well. So.
Oh man, we're so happy to hear about hot testing and first criticality and all that stuff.
Absolutely, it's been a very exciting past few weeks here at Westinghouse.
Yeah, incredible. Maybe you can give us just like a brief overview on those different reactor sizes, how many people they might serve, what sorts of use cases, if folks aren't really familiar with the different type of sizes.
Okay, so the 5 megawatt size is really aimed at serving communities, neighborhoods if you will, and really aimed at serving communities that currently are relying on perhaps expensive diesel being trucked in or don't have a reliable grid system. So it's almost where a community can operate off the grid if they have an eVinci or two in their midst. Moving up in size, 300 megawatts for an SMR concept is really ideal for communities that either need just a little bit more power or they've never had nuclear power and they're sort of dipping their toe in the water, so to speak. 450 megawatts for our lead-fast reactor concept. That concept actually has many other benefits in addition to the electricity that traditional BWRs and PWRs provide, as does our eVinci concept. It operates at a higher temperature and it operates at ambient pressure. And so it will have a smaller footprint than might be needed for a traditional 450 megawatt PWR or BWR concept. which means that it can be placed closer to communities, closer to urban centers. So that's another benefit of that. And then for AP1000s, that gigawatt-sized reactor can power large cities. So 500,000 people to 1 million people, depending on how many units you have. And that's we can see that happening very successfully in Sanmen and at the high-end plants in China, and then of course at Vogtle 3 and 4, soon to be powering those hundreds of thousands of people in those communities.
Amazing. From your perspective and your experience interfacing with the Nuclear Regulatory Commission, do you think we'll be able to get these reactors licensed on a timeline that'll be, compatible with building a whole bunch of them?
So what Westinghouse is doing is we have been submitting white papers and topical reports to the NRC. We have been meeting with them quite frequently so that the staff at the NRC are kept up to date on what we're doing. We respond to, if it's an informal meeting, we respond to their questions in the informal manner. If it's a formal meeting, we respond to those requests for additional information as appropriate. So I think the key is to be communicating early and often, which is a key for any industry, I would say, with any stakeholder. So it's nothing novel, but it takes time, it takes resources, it takes planning. And Westinghouse has been in this business for decades, and so we know how to interact not only with the NRC in the United States, but with regulators around the world. And so we're following that model, that experience that we have, and we're optimistic that when the time comes to license these different designs that have not yet been licensed, we'll be successful. The SMR concept that I talked about is actually a shrunken down version, if you will, of our AP1000. So it's really based on proven technology, based on constructed technology. So we also anticipate that, yes, of course we have to license it, but it may not see as many hurdles or barriers as maybe some other concepts we might anticipate them seeing.
That's good to hear. What do you think is the coolest thing about nuclear energy?
Oh boy, I think the coolest thing, and this actually kind of speaks to my career as well, I started out in nuclear for applications at sea, right? And now I'm working in terrestrial applications, and I have for quite a while. But Westinghouse is actually partnering with NASA to develop a reactor for fission surface power on the moon. And so sea, land, and space is really a great story that we can tell that nuclear applies to all of these different missions. And so while it's a great technology to provide power, I'm really also very proud of the fact that our technology, nuclear technology, creates medical isotopes that save lives. And that is really a lot, that importance has been heightened a lot more over the past, unfortunately, the past 15, 16 months, geopolitically speaking. A lot more emphasis is being put on making medical isotopes, generating those in friendly countries, if you will.
Speaking of the last 16 months, maybe some might say it's exposed some vulnerabilities in the global fuel supply chain. Do you think we need to be making it easier for our friends and allies around the world to help us, have a reliable supply of fuel, to ensure that we can export reactors? Maybe talk to me a little bit about kind of your perspective on export controls right now, or Section 123, for example. I don't want to get you in trouble with anybody.
Right, and I've been a bit removed from that since my time at DOE.
Okay.
But what I will say is that it is really important. So Department of State and NNSA and those policies are really important to ensure that our allies and our friends abide by the rules that are set forth by those organizations. And especially Westinghouse, we're a global company. Export control is something that we train our teams on very regularly because it's easy to take a misstep, even innocently. And so export control is important. We have our legal teams that continue to provide us the latest and greatest updates on the policies and the laws. And we look forward to working with countries that may not have nuclear, they're going to be new to nuclear, and to be using this technology in a civil application in a peaceful manner.
Great. For somebody who maybe is just kind of stumbling upon this technology, doesn't know that much about it, maybe isn't sure if nuclear is harmful or helpful to the environment, what would you say to them?
So I would say that I am a materials engineer. I did not study nuclear engineering in college, but it has been, I've been in nuclear technology and that space for my entire career. And the reason I choose to stay here is because I firmly believe in my heart of hearts that this is the technology that will help us save the world. It can provide electricity to those that already have it. It can provide electricity to those that need it. It can provide the heat and the electricity that's needed for desalinating water, so that when the water crisis that many nations are seeing around the world becomes an emergency, and I think we're on the brink of that, nuclear power can help with that in a clean way. Currently, desalination is a pretty fossil-intensive process, and to be able to displace that process with a nuclear clean green desalination process is, I find it as a double win. You're providing clean electricity to a community, but also being able to desalinate their water cleanly as well. We talked about generating medical isotopes, so creating life-saving medicines and isotopes for cancer detection and cancer treatment. That's very important. Providing district heating, providing heating for manufacturing processes that are clean. All of these things are really, they're all wonderful features of nuclear technology. I'm a mother of two children, and I want them to inherit and live in a world that is better than what I grew up in. And I, again, firmly believe that nuclear power will absolutely contribute to that.
Thank you so much for speaking. Anything else we didn't cover that you'd like to add at the end?
No, I just want to reiterate that I am grateful for the work that the community is doing. I'm grateful for the work that Generation Atomic continues to do. I've known you and GA for quite some time, and I'm thrilled to see the impact that you all have had on this community. It's really important, the work you do, and please keep doing it.
Appreciate that so much.